Yeah, so it's like that one. You see here we have low pressure. That means in the container, the volume is more. That time the pressure is low. If you are decreasing the volume, that time you see because of this decreasing volume, the molecules are coming very closer to each other. Then they are colliding with the wall more, right? If the volume is less, then the same number of molecules they are colliding more with the wall now. Every unit area now. Okay, so force per unit area. If you decrease the area, then there will be more pressure. Is it clear? Hello,
Yes, sir.
hello. So it is one way to increase the pressure. There is another way, if you have the same volume, but you are increasing the temperature, then what happens? Here it is. If you have the same volume of gas here, but you are increasing the temperature, here is low temperature, then medium temperature, very high temperature. So that time also we are getting more collisions with the molecules of gas. They will get more kinetic energy. Then they will hit the container wall with more force. Then the pressure will be more. Have you got it? Hello, everyone. Hello.
Yes, sir.
Okay. We have here some students. They might not be aware of the formula of pressure. For them, we will give you some ideas of pressure. Here we have learners. They know about the formula of pressure. Pressure formula is, you see, we write here the heading here, pressure and motion of molecules. Okay, of molecule. This heading you give. So you write here pressure equals pressure equals force per unit area. Okay, so force is coming from the kinetic energy of the molecules, right? The way, like if you are punching on the wall, your uh, kinetic energy, if it is more, then you are applying more force on the wall, right? Isn't it? Hello, hello.
Yes, sir.
So the same thing the molecules are doing when they are and colliding with the wall of the container. The container they are staying. If the force is more, then the pressure is more. From this formula, we understand. Okay.
Yes, sir.
Okay. So this is about the motion of molecules. So we write the explanation now. If the temperature increases, So you got it right, everyone? Hello?
Yes, sir.
How pressure and motion of molecules are interlinked, and how it is also linked with the
Yes,
temperature
sir.
increase. I think all of you are clear now. This is a unit area. Okay. So continue with greater force per unit area. Okay, done. Now, yeah, yeah. Please take a snap and send it to group, please. All of you. Who is sending? Only take the snap of this part, the writing part. You zoom your mobile screen, then you take this part only.
Done, sir.
Thank you so much. Okay, so we have here this learning outcome also done. Learning outcome D. Learning outcome D is also done. Now we are discussing some very common thing. We know all of us. I think you all are informed about this. You all know about this. What is melting and boiling? Can anyone please share your ideas? What you already know about melting and boiling? Please raise your hand. You can take part in discussion. Whatever you know about melting and boiling. Hello, Ravi, Lamisa, Advita.
Yes, sir.
Yeah, you know anything about melting and boiling? Could you please tell us?
Yes.
Yeah, please tell us. What is melting?
So melting is a process which of changing solid into liquid. and change in temperature without changing temperature.
without changing temperature. Very important thing. Yeah. So we know, we understand melting means turn from solid to liquid, right?
Yes, sir.
Like ice melts and turn to water. But when this process is happening, the temperature at that moment or during that time, we have the temperature constant. We know we can have more explanation of why it's like that. The temperature remains same. Like we know the um, ice. Ice cannot be ice if it is more than 0 degrees Celsius. It will turn to water because the point or the temperature when it starts melting, this is 0 degrees Celsius. Okay, and water, after it's turned to water, then gradually its temperature increases. Again, if you think of reverse way, you see here it's written melting slash solidification. So solidification or freezing, it's opposite of melting. The opposite happens when liquid turns to solid. It means water turns to ice. Water, if it reaches to 0 degrees Celsius, it turns to ice, and during this process, also the temperature remains same, that is 0 degrees Celsius. And this process, there is change in energy or transfer of energy. When it is melting, when it's melting, the ice is absorbing heat from the surroundings. External source, like we have like external source means the surrounding can be its external source, or we can give heat from anywhere, from the heater, from the stove, or anywhere we can give the heat. So here it is the crucial thing. Without a change in temperature, we have to remember it. Eh? Is it clear to you? Hello, hello.
Yes, sir.
So we have the definition of melting, and solidification or freezing is opposite of that. What is boiling? Can anyone try what is boiling? Yeah, Mariam, you can try what is called
Yes,
boiling.
sir.
Yeah, what is called boiling? Or you can say what you know about boiling. Just share your ideas with us. Then we can add, or we can, have something more with your discussion or with your ideas. Yeah, Mariam, you know anything about boiling?
So it's the point where liquid changes into gas, like the temperature point where liquid
Yes,
changes its
yes,
state to gas state.
yes. So we got the idea from here that when liquid turns to gas, this process is called boiling, right? And that is also
Yes, sir.
happening at constant temperature, like at 100 degrees Celsius. water, water turns to vapor. Okay, so when this boiling process is happening, that time also the temperature remains constant. It will be at 100 degrees Celsius. Then we have liquid turns to vapor. Is it clear? Hello, hello.
Yes.
Okay, okay. So the opposite of boiling, it is condensation. That time in condensation process we have vapor or gas turns to liquid. So we now have the idea of melting and boiling. These two are process, and we have also melting point and boiling point. That one we will have discussion. Now we deal with melting and boiling, these two process. So we write here mm, melting first. Huh? Yes. Adrita, you have another class, right? Adrita,
Yes, sir.
yeah, you can go, no problem. You can have another
Yes, sir.
class.
Hello?
Sorry?
Hello.
Yeah. You can join in other class, no problem,
Sir,
Adrita.
Assalamualaikum.
Okay, thank you. So we understand, Rabi, Lamisa, Monica, Mariam. Look, melting point is related to temperature, right? When we
Yes.
say melting, this is a process. The process is called melting, and when we say temperature, that is called melting point. The same thing. One is related to temperature. When you are pointing the temperature, that is called melting point. The temperature at which the temperature at which solid turns to liquid without any temperature change is called melt melting point of that object, isn't it? Like the melting point of ice is 0 degrees Celsius. So we can from here make the definition of melting point. Melting point. Sometimes we mix up what is melting point. We cannot say which one is process, which one is melting point. Just for you, we are giving you this information. Melting point is related to temperature. Okay, temperature at which certain solid turns to called melting point of that object. So from this statement, we understand melting point is different for different objects, right? Isn't it? So,
Yes, sir.
so melting point of ice is 0 degrees Celsius, but melting point of wax is around 50 degrees Celsius. At normal temperature, wax is solid, right? At room temperature, isn't it?
Yes,
Hello?
sir.
Melting point of different solid is we say here plural, melting points of different solids are different. So, Monica, could you please take a step of this part only? Melting, till here, melting points of different solids are different.
Done, sir.
Yeah, thank you. And now I'm showing you one diagram or one table where we'll get list of melting points of different objects. That one will help you understand more, right? Melting point of different solids. You write list. I'm writing here melting point of wax. So it has a range. It depends on the structure of the wax. So you
Sir,
write
the
here.
screen isn't shared.
Sorry.
The screen isn't shared.
Okay, it's not shared. Okay, fine. You do not need to, have it shared. I'm showing you, no problem. Okay. Now you are seeing that one, right? I'm writing. Yeah, melting. You write this a melting point. Then here write. Here you write object. So you make a table like this. Object is ice. You write here ice. Then you write here wax. Then you write here iron. These three only you write. No, we don't need so many things. Just write here. Then ice. How much you got ice? 0 degrees Celsius, right?
Yes,
Ice
sir.
you got 0 degrees Celsius. So it is 0 degrees Celsius. Then you got wax around 50. There is a range. You write here around 50 degrees Celsius. Around. We are writing around almost 50. And the iron you write around 900 degrees Celsius. Okay. Okay. Is it clear now? So take a snap here and send it to our group, please. Done, Monica?
Yes,
Hello.
sir.
Yeah. Okay. Thank you so much. We will continue from here. Okay. Thank you so much. Allah Hafiz.